Hello students, how are you? Today let us see some more questions from the GOC lesson. In my previous video, I have discussed some questions, NCERT examiner questions. Today let us see a little more difficult questions from the GOC lesson. Okay students? The first one is, which among the following is correct IUPAC name of this compound? This compound is given here. What is the root word? First we have to see how many carbon atoms are present, and in this it is in the options it is given as hex 1, 2, 3, 4, 5, 6. It is a 6 carbon and it is given as hex in all the options, and in these options the EZ configuration is applied and we have to check the double bond and triple bond positions. We have to apply EZ isomerism and also the priority rules. This compound has a double bond and a triple bond. Among double and triple bonds, double bond will be given more preference. So the double bonded carbon gets the least number. So we have to count from the right side to the left. 1, 2, 3, 4, 5, 6. So it will be 2 bromo, 2 ene, 2 bromo, 2 ene. It is 2 bromo, 2 ene, 4 ene. Okay students, so the option is D only, but here we have to assign EZ configuration to the double bonded carbon atoms. How to assign EZ configuration? EZ configuration is assigned to the carbon atoms by giving the priorities to the groups attached to the double bonded carbon atoms. Based on what we give the priorities? Based on the atomic masses. So here bromine and methyl group is present. Bromine will get the first priority. The group with the highest mass number gets the first priority. So bromine gets the first priority and methyl group gets the second priority. And in this carbon, on this carbon, this entire group is present on one side and hydrogen is present on the other side. So this entire group gets the first priority and hydrogen gets the second priority. First priority groups are lying on the opposite side of the double bond. So as first priority groups are lying on the opposite side, the configuration is assigned E configuration. E means NZ, which is opposite. Okay. So it is 2E. In both the cases it is given as 2E only, and 2 bromo hex. It is the first one 4 ene and 2 ene. 4 ene and 2 ene are given, and in the last option 2 ene and 4 ene. Now here the numbering is also correct in both the cases, but what is the correct answer? The correct one is D, because ene should be written before ene. Ene should be written, the double bond is represented, the double bond is written before the triple bond. So the correct answer is 2E, 2E, 2 bromo, hex, 2E, 4 ene. Okay students, the next question is structure. This structure shows which kind of isomerism. And this structure has a double bond and it has a chiral center. A double bond and a chiral center. In the options, geometrical isomerism and optical isomerism, both A and B and none. It has a chiral center. What is a chiral center? A chiral carbon is the one which is bonded to 4 different groups or atoms. It has this carbon as a chiral carbon, so it shows the optical isomerism. And also it has a double bond. Whether it shows the geometrical isomerism or not, can it shows the geometrical isomerism? It cannot show the geometrical isomerism because on the double bonded carbon identical groups are present. These two are methyl groups which are identical. So it cannot show the geometrical isomerism. So this compound shows only optical isomerism. B is the correct answer for this. Now let us see one more question, students. This structure. See the structure. This structure on hydrolysis in aqueous acetone gives what? Here 3 products are given. A, B, C products are given and these are the options. Now hydrolysis means here this carbon has one halogen, this carbon, this chlorine will be eliminated. This structure has one halogen, chlorine. This chlorine is eliminated on hydrolysis. Okay. So on the elimination of chloride ion, it forms a carbonium ion. It forms a carbonium ion. Okay. It forms a carbonium ion, and on either side of this structure, benzene with nitro group and one methoxy group. Benzene ring with methoxy group and benzene ring with nitro group is present on either side of this structure. Now what is the nature of this nitro group and methoxy group? On the hydrolysis, this chloride ion is eliminated and it forms the carbonium ion. This methoxy group is an electron releasing group and nitro group is an electron withdrawing group. So what happens is, this carbonium ion, even though it is stable, this hydride ion will migrate towards this carbonium ion, giving carbonium site to this carbon also. So it forms a mixture of compounds in which the hydroxyl group is present at this carbon and also at this carbon. Okay, students. Now here in the first option, hydroxyl group is present in the middle carbon. So A we will get, and in the second option, by the shifting of hydride ion is present on the center carbon and OH group is present on the position where hydrogen is present. So we will get B also, and in the C option, by the migration of methyl group, the carbonium ion is formed at the adjacent carbon. But here this product is not formed in the reaction because nitro group is an electron withdrawing group. It will not allow to migrate this methyl group towards the adjacent carbon. So the carbonium ion is not formed at this position. At this position, the carbonium ion is not formed. Only at the center carbon and on the left side where hydrogen is present. Where hydrogen is present, by the migration of this hydride ion, a carbonium ion site is formed on this carbon. So hydroxyl ion will be substituted at this carbon and at this carbon. So we will get a mixture of A and B but not C. So in the options A, B, in the A option A, B is present. So A is the correct option for this question. B, C, A, C, A, C. C is not at all formed in the reaction. And the reason for the migration of the hydride ion is methoxy group on the left side and nitro group on the right side. It is an electron withdrawing group and this is an electron releasing group. It is an electron releasing group. So it will allow the hydride ion to migrate to the right side. So this A and B are formed in the reaction. Okay, students, it is a very interesting question. which came in IIT advanced question paper. Now the next question, which is not formed in this reaction. This is the reaction which is an electrophilic substitution reaction, and it is the third electrophilic substitution on the benzene ring because already two substituents are present on the benzene ring. And what is the nature of these substituents present on the benzene ring? The hydroxyl group is an electron releasing group and nitro group is an electron withdrawing group. When these two types of groups are present on the benzene ring, the effect of electron releasing group overweighs the effect of electron withdrawing group. So this group will not work. The effect caused by the electron withdrawing group is not observed in this third electrophilic substitution. So we will see the products in which the third electrophile is present either ortho or para to the electron releasing group, that is the hydroxyl group. So let us see the options. In the first option, the third electrophile is present at para position to the hydroxyl group, so we will get this product. And in the B option, the third electrophile is present meta to the hydroxyl group, so you will not get this product. And the third electrophile is ortho, so we get this one, and it is also ortho, so we get this one. So the answer for this question is B, where the third electrophile is present meta to the electron releasing group. This product we will not get in this reaction. And also theoretically these three are possible, but practically this C is not possible because two bulky groups are present, and if the third electrophile wants to be substituted in between these two substituents, it is quite difficult. Due to steric hindrance, the third electrophile cannot come and occupy the position in between these two substituents. So practically this is not possible, but theoretically it is possible. Okay students. The next question is the correct order of dehydration of these following three. Which undergoes dehydration faster? In this is already having three double bonds. It is benzene ring, so it has already conjugated double bonds, and this has one double bond and it has two double bonds. In this, if this hydroxyl group is eliminated, if you want to do the dehydration, the hydroxyl group and hydrogen should be eliminated as water molecule. Which hydrogen is eliminated? The hydrogen present on this adjacent carbon. On the elimination of this hydrogen, there is a formation of double bond here. So this undergoes dehydration more readily because it forms more stable benzene ring. Benzene ring which has a conjugated double bonded system. Okay. So 3 undergoes dehydration more readily, and among this 1 and 2, 1 is already stable. One is having already stable benzene ring, so it will not undergo dehydration more readily. And this second one, on undergoing dehydration, it forms a conjugated double bonded system. Hydrogen is eliminated from this carbon and it forms a conjugated system, so it undergoes dehydration more or less readily. So the order of this dehydration is 3 readily undergoes, 2 also undergoes, but 1 will not undergo. So 3 greater than 2 greater than 1 is the correct option. 1, 2, 3. 3 greater than 2 greater than 1. This is the correct answer for this question. This is another question. Which of the following has lowest dipole moment? Dipole, the unsymmetrical molecules show the dipole moment. It is a cis compound. Hydrogens are present on one side and methyl groups are present on the other side. So it shows the dipole moment. And here it is a triple bonded substance on which hydrogen is present on one side and the ethyl group is present on the other side. So this also shows the dipole moment. It is an asymmetric molecule, unsymmetric molecule, and this one, it is a cylindrical molecule. Methyl groups are present to butyne. Methyl groups are present on either side of the triple bonded carbon atoms. It is a cylindrical molecule, so it shows the least, almost zero dipole moment, and it shows the dipole moment because double bond triple bonds are present. It is an asymmetric molecule. It shows the highest dipole moment mostly. So option C is the correct answer for this question, which has the least dipole moment. It will be having almost zero dipole moment because it is a cylindrical molecule and symmetric molecule. So C is the correct answer for this. Okay, students, hope you like all these questions. I think I have covered all the types of questions in my 2 videos. This type of questions, if you solve, these will be very useful for writing all the entrance examinations because GOC is a very important topic. If you are thorough with all these electron displacement effects and isomerism, definitely you can solve 2 or 3 questions which come from the GOC, and based on GOC only you are going to get the questions from the remaining part of the organic chemistry also. So you can solve any questions from the organic chemistry if you are thorough with the GOC. Please like and share my videos. I am going to upload more videos which are useful for all the entrance examinations. Thank you.